Today we're going to look at heart actions. So we'll be looking at blood pressure, EKGs, actions that your heart does, sounds that go with your heart. So the cardiac cycle consists of your atria beating, which is called systole, followed by your ventricles contracting, which is called ventricular systole, and then the entire heart relaxes for a short moment, and that moment is called diastole or diastolic pressure. So when something is contracting, it's in systole. When something is relaxing, it is in diastole. So your atrium contracts, then your ventricles contract, and they go in a cycle, in a rhythm, in a pattern. So during the cardiac cycle, pressure in your heart chambers are going to rise and fall depending on how much blood is in there and depending on whether they're contracting or relaxing. So when your atrium fills up, so the top of the heart, your two atria, when the atria fill, the pressure in the atrium is going to be higher. That's where the blood is at. The top part of the heart is full. So it's greater than that of the ventricles. That pressure forces your AV valves, which are your bicuspid and tricuspid, forces those open so that the blood can drop into the bottom of the heart. Pressure inside the atria rises further when that muscle actually contracts or squeezes, forcing the remaining blood into the ventricles. So your atria get full, blood drops to the bottom of the ventricles. That contraction forces out the remaining blood that hasn't dropped through or fallen into the ventricles. When the ventricles contract, pressure inside them in the ventricles is going to be higher than the atrium. That causes the AV valves, the ones that were open, now to close. So now my bicuspid and tricuspid are closed. And then my aortic and pulmonary valves are going to open because that's where the blood leaves the ventricles. When the ventricles contract, those papillary muscles inside of the heart pull on those chordae tendineae, making sure that blood does not go back up into your atrium. We do not want blood leaking backwards in the heart. And then, next step goes back. The atria are going to fill again and get ready for the next cycle. So atria fill, pressure increases there. Blood goes to the ventricles, pressure increases there, and it is a repetitive cycle. Once the blood is pushed out of the ventricles, the pressure in the ventricles drop, and then it drops even more as the ventricles relax. So when the ventricular pressure is lower, then the pressure in the aorta and the pulmonary trunk, then the aortic valves and the pulmonary valves are going to close. So your heart valves, whether they're your AV, bicuspid, tricuspid, or your aortic and pulmonary, which are your semilunar valves, they open and close based on that force and pressure of the blood that's in those cavities. Once the ventricle pressure is less than the atrial pressure, so the pressure on the bottom is lower, the pressure on the top is greater, the AV valves open again, and blood drops back into the ventricles. And like I said, that process goes over and over. So here's a diagram kind of without the blood in it. So what happens is when these valves are open, so these are called your AV valves. So my tricuspid and bicuspid are open. They are letting blood fall into the ventricles. If these valves are open, my semilunar, so my pulmonary and my aortic are closed. When these are open, these are closed. So blood comes into the bottom, into the ventricles. Then, when blood is going to leave the ventricles and go out these valves, your AV valves close and allow blood to start coming into the top again. So notice here you can kind of see that the bottom has squeezed in. So your heart does not beat or pump right side, left side. It is top contracts, bottom contracts. Top contracts, bottom contracts. So that is the lub-dub sound that you hear in your heart. And those sounds deal with basically the valves are what you're hearing. And there's a student I had many years ago that had very bad, I don't remember, I think it was the bicuspid valve. Had a PIG valve installed when she was in middle school. And then in high school, she had a titanium, actually maybe she had graduated, maybe she was in college. Had a titanium valve put in because they last longer. And instead of hearing like the lub-dub, you'll hear like a little click. You can actually hear the clicking of that titanium in her heart. So the typical sound of a normal heart is lub-dub. The first sound, the lub part of it, is when your AV valves are closing. So basically you hear a thump, 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 thump when you listen to your heart. So that first sound is the AV valves closing, your bicuspid and tricuspid. The second sound is when your aortic and pulmonary valves are closing. So those are the sounds that you're going to hear. And then an abnormal heart sound is called a murmur, a heart murmur. And those are very common. I wouldn't be surprised if any of the students that I have a heart murmur. And that typically comes from valve damage. And you can have a slight heart murmur that's not going to bother you at all. Or you can have a major valve damage where you do have to have a new valve replaced. So here, this diagram, probably not my favorite. You have to look at it fairly closely. But what it's basically showing is your different pressures and then the amount of blood that's in there. So here, I can see my ventricular volume rising. That's going to affect my pressure. What I do want to pay close attention to today is we will get into an ECG or an EKG. So this one right here is the diagram that I am going to want you to understand. I will not have a diagram like this on the test. This one is very likely that I will. So inside of your heart, you have a mass of merging fibers. It's called a functional syncytium. One is in the atrium, so it's the atrial syncytium, and one is in the ventricle, so it's the ventricular syncytium. These syncytia, plural, are separated by the fibers of the skeleton. So remember, a muscle cell is called a fiber. So you have heart, cardiac muscle fibers, and they bundle together as a mass, and that mass of heart cells is called a syncytium. Also inside of your heart, there's specialized cardiac tissue that's going to allow nervous impulses to go throughout the heart. And that's called the cardiac conduction system. This one you hear more about, this one there's more abnormalities with. So inside of your heart, you have a self-exciting mass of cardiac muscle, and it's called the SA node. I want you to sinoatrial, it's found in your atrium. The SA node, it is the natural pacemaker of your heart. If you know someone that has an artificial pacemaker of your heart, of the heart, it's inserted because their SA node does not work properly. So the SA node is in the right atrium, and it is what constantly tells your heart to beat. It generates that impulse that keeps your heart beating at a proper rhythm. So if that SA node is not working properly, people will have an artificial, a pacemaker inserted that will cause that impulse to start. So what happens, the SA node sends an impulse, and those impulses are going to go through the atrial syncytium, which are your muscle fibers, and it's going to contract the atrium. Those are going to travel down, and then there's an AV node, which is the second spot, and it's located in the septum, or the center of your heart, and that's going to then send the impulse to your ventricles to contract. So these fibers are very small. They allow the atria to contract before that impulse goes to the ventricles. I want my heart to beat properly, so top, bottom, top, bottom. I can't have them both going at the same time, or we're going to have a mixture of blood and we're going to have a mess. So the atrium have to contract before that impulse goes to the ventricles. The delay through these fibers allows your atrium to contract together first, and then your ventricles to go second. So from the AV node, that impulse is going to pass through a bundle, so AV bundle, as it travels through the entire septum, and then the Purkinje fibers branch off, and the Purkinje fibers basically surround your ventricles, and that's going to cause them to contract. So these Purkinje fibers stimulate contraction of the papillary muscles and the ventricles, and cause basically the bottom of your heart to have a twisting, upward, pushing contraction. So picture, I do want you to know all the parts of the conduction system. So the SA node is at the top of your right atrium. Your SA node is what signals your right atrium and your left atrium to contract. SA node first. Then these impulses reach the AV node, which sits basically AV in between your atrium and ventricle. And then there's a short little AV bundle. That AV bundle then is going to branch into two branches that's going to surround the left ventricle and the right ventricle. And notice it goes through the septum of the heart. And then the Purkinje fibers are the ones that lead up into the ventricle and into these papillary muscles that will contract. So SA node sends an impulse. Atrium contract. Slight delay, AV bundle sends the signal that goes through the branches into the Purkinje fibers. The ventricles contract. So first, second. First, second is the way that works. So here's a good review, maybe just highlight that. This shows the order that it goes in throughout the heart. Goes with the picture that we just looked at. So starts in the SA, atrial syncytium, remember, are just the fibers of the atrium. Goes to the AV node through the short bundle, it branches off, goes to your Purkinje fibers.